Hey guys, welcome to the 8th tutorial in the AI series. In today's video, we are going to take a look at what is linear regression and how does linear regression actually work. So let's get straight into it. We know regression predicts a number by drawing a curve through the data. So let's make the simplest curve there is, a straight line, and let's understand everything about it. Linear regression is the workhorse of the entire field of machine learning. It's fast, it's interpretable, and the ideas we meet here, such as fitting, error, optimization, are the same ideas that scale all the way up to giant models. Once you master linear regression, you quietly learn the base and the skeleton of almost everything related to machine learning. A straight line is nothing more than a function with two knobs. Y equal w times x plus b. These two knobs are exactly the parameters we talked about back in the supervised learning video, which are w and b, and now they're made concrete. The first, which is w, signifies the slope of the line, how steeply the price climbs as the size grows. And if we change the w value to make it higher, the line tilts steeper. The second is B, which is the intercept, where the line sits vertically. If we turn it up, the entire line lifts, and that is the entire model. Two numbers. The whole task of learning here collapses to a very simple question. What are the two numbers we must choose so that it's absolutely perfect? To predict, we pick a size on the bottom axis and go up to that line and read the price across. That value is the model's guess, and that is written as y hat with a little hat to mark it as an estimate, which is carefully distinct from y, the true price of the actual house. So y hat is the estimated price. So y hat is the estimated price of our model, and y is the true price of the actual house. And for every real house, the gap between the true price and the line's guess, which is y hat, is the residual. Simply how much wrong we were on that one house. And hold on to these residuals because they're about to become the single most important quantity in linear regression. Now, real prices don't just depend on the size of house alone. There are bedrooms, the age of the house, and each and every one gets its own knob. So we can say the model becomes y equals w 1 times size plus w 2 times bedrooms plus w 3 times age plus b. Geometrically, the line flattens out into a plane, tilting through a higher dimensional cloud, and with many features, a flat sheet in a space you can't picture. And here's the quietly powerful part. The reason people reach for linear models even today is because these weights are readable. A weight tells you exactly how much its feature pushes the price, holding the others fixed. And its sign tells you the direction. A big positive weight on size, a small one on age. The model is literally telling you in plain numbers what it think matters and by how much. Very few models are dishonest about their own reasoning. Now, there's a huge misconception worth killing because it trips up even strong people who are pretty good at linear regression. Linear regression does not mean it can only ever draw straight lines. If I take my feature size and also feed the model size squared as an extra feature, the very same linear machinery can now bend into a curve. The trick is that linear regression is linear in its parameters, the weights, but not exactly in the inputs. So, by inventing new features out of old ones, squares, products, logarithms, a linear model can fit beautifully curved out relationships. That's called polynomial regression, and it's still underneath the exact same two settings per feature idea, which is W and B. So, here's a question for you to find out. If a straight line and a wild curve can both come from linear regression, what stops us from just adding features until it fits every point perfectly? And this leaves us to exactly the main point of this video. Your eye can roughly spot a decent line, but a computer cannot really look at anything. It needs a single number that says how good a given line is. A number it can systematically make smaller and smaller until the line is the best one possible. So, turning this vague wish, where we hope that all the residuals are small, is the honest score of the job of the cost function, which is the very next video. If this video helped you understand how does linear regression actually work, then make sure to subscribe and hit the like button for more videos like this.